All right, physics students, we are moving on. Equation of motion, okay? I can calculate and represent graphically the position, displacement, speed, and velocity of an object in one dimension. We're in one dimension right now. We will soon be in two dimension. So this still has something to do with position versus time curves. So who cares about position versus time curves? Well, lots of people do, because we can actually use it to develop a mathematical relationship between the position and the time and make predictions about that. So as you've learned, we can have position. It can be described as a function of time, as shown in previous sections. And the rate of change of position per unit time is constant. This relationship, if the relate, is considered to be linear. If the rate of change per unit time is constant, then I have a line. It's linear, okay? And that's actually what I have shown on this graph. That is a linear relationship. The rate of change of the position versus time is constant. No matter where I calculate the slope on that, I'm going to get the same value. So let's do some recollection of what the equation of a line is. I got y equals mx plus b. That's in the slope-intercept form, where slope is usually designated by the symbol m, and b is the y-intercept, the value of y when x equals 0. Okay, so here we have this position versus time curve. And what does the y-intercept represent? Well, here's the y-intercept. That means where I'm at time 0. That is considered its initial position. That's where it's located at time 0. There's xi. What does the slope represent? Okay, well, if we look at the slope, which is the rise over the run, just look at units. What is the rise? Well, what are the units of the y-axis? What is the run? The units of the x-axis is seconds. That's meters per second, and that is velocity. All right, so substitute into this equation those items, and we get, let's see, first off, what is x in this situation? X is time, right? So now we have, we know the slope is velocity. We know that what's on the x-axis is time. Okay, so there's the variable. Velocity is constant in this situation. What is the intercept? That is equal to the initial position. And y in this situation is the output. That is what is going to be on what is on the y-axis? Position. So at some time in the future, where is my position? So that's going to be considered its output, which is its final position. So there is our first, there it is, velocity times time plus the initial position. There is our first equation of motion. Congratulations, you just derived it. And this kind of gives you some a better example of how that was derived, the y equals mx plus b, and where all those things came from, okay? So you have just developed your first equation of motion. And here it is again. This is what it looks like in your book, okay? So by the way, that is the average velocity in there, in that equation. And what do we do when we want to take the average? We add the two values up and we divide it by 2. And in this case, the average velocity is the same, right? I mean, the initial and the final velocity is the same. It's always constant, but it's not always constant. Right now, we're dealing with acceleration is equal to 0. We're not accelerating. This guy has a constant slope, constant velocity. You're driving down the road at 10 miles per hour forever and ever and ever. You're not accelerating, okay? So eventually we're going to deal with acceleration and velocity will not be constant, and then we will have to evaluate that. So let's do an example. Skateboarder with an initial position of 1.5 meters moves with a constant velocity, velocity equals 3 meters per second. Write a position time equation for of motion for the skateboarder. So what is our form? Velocity time plus xi. Well, x final is equal to, what is the velocity? 3. And we can put meters per second there. And I have time. We don't know what the time is. We can pick a time, and we know that we have 1.5 meters. So there is my equation of motion for this situation. So that is the answer to A. And then B. What is the position of the skateboarder at time equals 2.5? Well, I just take that equation. F final is equal to 3 meters per second. Multiply it times 2.5 seconds plus 1.5 meter. And have I worked a problem, or do I have to do it myself again? I have not worked the problem. I can't do anything in my head, by the way. So 3 times 2.5 plus 1.5, 9. So I get the final position is equal to 9 meters. And when was that? That was at 2.5 seconds. Okay, so there is my answer to B. So let's do number 35. The position time equation of the motion for a bunny hopping across a yard is X final is equal to 8.3 meters plus 2.5 meters per second times time. What is the initial position of the bunny? Initial position is the intercept, the y-intercept. That would be, and by the way, you could use units to answer this question, right? That is 8.3 meters. What is its velocity? That's the slope, 2.2 meters per second. For 36, so I have a bowling ball. It moves with a constant velocity from an initial position of 1.6 meters to a final position of 7.8 in 3.1 seconds. This one's a little bit more challenging. So here we go. An X initial is equal to 1.6 meters. X final is equal to 7.8 meters. And they told me that the time to do that was 3.1 seconds. Now, the first thing they want me to do is write a position versus time equation for the ball. What is that format? The final position is equal to the velocity times the time plus the initial position. I have to know the initial position and the velocity in order to complete this problem. They tell me the initial position, but I don't know the velocity. They didn't give it to me, but they gave me enough information to calculate the velocity, because my definition of velocity is change in position over change in time. So what is the change in position? The change in position is 7.8 meters minus 1.6 meters divided by 3.1 seconds. And I believe that comes out to 3 meters per second. So let's figure that out. 7.8 minus 1.6 divided by 3.1. Be helpful if the calculator was on. Enter divided by 3.1. I'm sorry, it comes out to 2. So velocity is equal to 2 meters per second. I'm going to double check that. I almost always have to get the same answer twice. Okay, 2 meters per second. Now I can finish this problem. X final, so that's going to be wherever the position is at whatever time I decide, is equal to the slope, which is 2 meters per second, times time. So at time, whatever you choose, I can predict the final location. And I have plus the initial position, which they told me is 1.6 meters. Okay, so there is my equation of motion for the object that they described in that problem. Now, B, at what time is the ball at position 8.6? This is the whole point of having an equation for motion. Now I can make some predictions. So I'm going to find the time that the ball is located at 8.6 meters. That will be its final location, 8.6 meters, okay? And so I want to know at what time. So I'm going to use this equation to solve for t. So I've got to rearrange that equation. So I can put 8.6 meters is equal to 2 meters per second times time, which is what I'm looking for, plus 1.6. So I'm going to subtract 1.6 from both sides. So 8.6 minus 1.6 equals, so I get 7 meters is equal to 2 meters per second times time. Now I have to divide both sides by 2, and I get time is equal to 3.5 seconds. And that is the answer for part B. Okay, so I've developed an equation of motion. I have now used it to solve something. Okay, number 37, the position versus time graph shows the motion of two cars, A and B. Is the velocity of a car A or B, is the velocity of car A greater than, less than, or the same as the velocity of car B? Well, this is a position versus time curve. So the slope is equal to the velocity. And how do I know that? Because the slope is in units of meters per second. And I don't know, I don't even have to calculate it. I hope that you can see that the slope of B is greater than the slope of A. So the velocity of A, whoops, not A, B, is greater than the velocity of A. Okay. Is the initial position of the car A greater than or less than or equal to the initial position of car B? Well, where is my initial positions? Initial position of A is located at approximately 12 and a half, right? And the initial position of B is approximately 5 meters from the origin. So the A is greater than B. In the time period from 0 to 1 second, 0 to 1 second, is car A ahead of B, behind car B, or the same position as car B? Okay, let's erase some of these things so we can see what we're doing. Once again, between the time 0 and 1 second, is car A ahead of car B, behind car B, or at the same location? So between 0 and 1, here's A, 0 and 1. Here's B, 0 to 1. At no time has B passed car A. So car A is ahead. It's catching up, but it's still ahead of car B because its position at all times is greater than car B, as seen by the graph. Okay. All right. So that is the end of my lecture for today. However, my assignment is to complete numbers 42, 43, 44 for your homework. Okay. Number 45 is challenging. We'll work on that tomorrow. Have a great day and come see me if you have any questions.